Hi, we'll start this section on rotations with simple rotations about the origin. So a couple things to see here. In the coordinate plane, we can use these rules, but we're always rotating around the point 0, 0, the origin. And in keeping with mathematical convention, we are going to be rotating in a counterclockwise direction. And as you can see, we have, just like the last section, we have several rules for these transformations, particularly for a rotation of 90, 180, and 270. A 360, of course, will map it onto itself. So let's look at this as an example. I'm going to start with a point 2,5. Now, if I think of it as 2 in one direction, 5 in the other, imagine if I were to rotate this L shape 90 degrees. You can see it's going to put me 5 to the left of the origin and up 2. And therefore my 90-degree rotation of this point is going to be -5, 2. Just like it says here, 2, 5 maps to the opposite of 5, 2. Let's rotate it a little bit more. Keep going till we hit 180 degrees. And now you see we have 2 units to the left and 5 down, otherwise known as -2, -5. So this original point, 2, 5, maps to -2, -5. Rotate it a little bit more for our 270 degrees. And you see now we have 5 in the x direction and 2 in the negative y. And I would end up with the point 5, -2. So these are the rules, or the coordinate rules for rotating around the origin. Remember, we're rotating around the origin and we rotate counterclockwise. Well, let's look at our rotations another way. And we're going to look at them with matrices. Just like last section, where we were doing reflections, we have multiplication matrices, that is our transformation matrices for our various rotations around the origin. We have a 90-degree rotation. This would signify my 90-degree rotation. Our matrix as follows. 180-degree rotation. A 270-degree rotation would look like this. And finally, the 360 rotation, which is very interesting because when I rotate it, it comes back to the pre-image. And you'll notice that this particular matrix is the identity matrix. So there again, keep these in mind because we'll be doing some samples using matrix multiplication. In this rule, we're going to use the coordinate rules for the rotation, and we're looking at rotating this quadrilateral JKLM around the origin 180 degrees. So let's look back at the rules for rotation. For a 180-degree rotation around the origin, a point AB will map to -A, -B. So this ought to be pretty quick. 1, 4, -1, -4. 5, 5, -5, -5. 7, 2, -7, -2. 2, 2, -2, and -2. So let's see if we can plot all those points. We do that, our figure ends up here. If we wanted to visualize the actual animation, it would rotate like this. There's another way of looking at it. Let's suppose I connected all the vertices. If I connect K to K prime, you'll notice that it is collinear with the origin, as is L with L prime, J with J prime, and M with M prime. In addition, another thing you can consider is that since J and J prime are equidistant from the origin, they would be on the same circle or arc centered at the origin, as would M and M prime, K and K prime, L and L prime. The more ways you can think of it, the better you'll understand it. So there we go again, and that is done strictly with the coordinate rules for a 180-degree rotation. And here's another example where we're going to use some matrix multiplication to perform a rotation. So in this case, we're going to make a 180-degree rotation of this blue triangle, JKL. This is the pre-image. And, well, let's see. We've got, make sure we've got it plotted right. We've got 1, 1, coordinates of J. And we've got over here, we've got 2, negative 1. And that would be the coordinates of K. And 0, 3, coordinates of L. So that's the pre-image matrix. And this is the transformation matrix, which is going to rotate it 180 degrees about the origin. And just like we've been doing so many times before, first row times first column. And so we see there negative 1 times 1 plus 0 times 1, and that's going to give us negative 1. Second row times first column. 0 times 1, negative 1 times 1, and let's see, we'll get a negative 1 there as well. Let's go through the rest of them. First row, second column, negative 1 times 2, and that's going to give us negative 2 for first row, second column. Let's do a few more here. Second row times second column, and that product, of course, will go here in the second row, second column. 0 times 2, negative 1 times negative 1, and that gives us a total of 1. Now, 2 more to go. First row, third column, negative 1 times 0 plus 0 times negative 3. And as we'd expect, that's going to be a 0. And finally, 0, negative 1, or 0 times 0, plus negative 1 times negative 3. And that will give us 3. And that would end up in the second row, third column. That's the last of it. And let's see if it makes sense. Well, we'll take our figure and we'll rotate 180 degrees. And let's see, J prime ends up at negative 1, negative 1, right over here. K prime at negative 2, 1. L prime at 0, 3. Something interesting we could do here, just for visualization, you will notice since each of these points is being rotated around the origin 180 degrees, they'll all be collinear with the origin. J and J prime, L and L prime, K and K prime. In each case, these 2 points and the origin are collinear. And I think that's about it. Well, I suppose by now we're getting pretty good at this matrix multiplication. This time I'm going to start with a pre-image matrix, and we're going to take this, the transformation matrix, for rotation of 270 degrees counterclockwise about the origin. Well, I suppose we should plot this thing first. Let's plot P. Negative 4, 2, negative 2. Oh, come on. Can we do that? There is our pre-image down there. So let's do the math. We're going to multiply, again, first row times first column. And We've been doing this over and over. 0 times -4, 1 times -4. So the element over here, which is in the first row, first column, -4. Second row times first column, -1 times -4 is a +4. Plus 0 times -4, and we see what we got there. Next column, oops, missed. Let's try this. Let's go with the first row, second column, 0 times 2 plus 1 times -2. And that's going to go in this spot, which is the first row, second column. Second row, second column. -1, or the opposite of -2, or sorry, the opposite of +2, which we all can see is -2. Hey, let's speed this up. We're getting this down. First row times the third column, 0 times 2, 1 times -5, and of course, in position row 1, or row 1, column 3, -5. Next, let's take that last row times this column, and we can see that we get a -2. One more. First row times the last column. 0 times -4, 1 times -7, and that's going to give us a -7. And finally, the last row times the last column, -1 times -4, and that's going plus 0 times -7, and I'd say that's, if I can find it, that'd be good for a 4. So there you have it. We have yet another one of our marvelous matrix multiplications. And let's just graph this thing. I suppose we could just, well, I'll just put it right up there, and we can imagine it looked a lot like that. So there it is, 270 degrees rotated about the origin. Now this is exercise number 24 from your textbook, and it's pretty interesting. We're going to take the pre-image, triangle ABC, rotate it 90 degrees about the origin here, and we just want to demonstrate by finding slopes that each of the corresponding sides is perpendicular to its image. Well, first off, I suppose we should rotate the figure. And how do we do that? It looks like that. Well, I already have it done for you. We've already mastered that bit. So let's review slopes. BC is clearly a negative slope. And of course, B prime, C prime is over here. That's its corresponding slope. Now I could put the grid in if it helps you see it, but you know the slope formula by now. So -3, +1/3. They are opposite reciprocals. So check. They are perpendicular. How about AB? Clearly a positive slope. And we'll look at A prime, B prime. Most certainly a negative slope and a bit steeper. So -5/2, +2/5. Again, opposite reciprocals. Done. And one last set. The slope of AC, that's a -1/6. And the slope of A prime, C prime, +6. Now these, well, without extending them, it's a little more clear that these two are perpendicular, but all of them, all three of those pairs, were perpendicular lines. Well, here we go with an old school construction. We're going to take this given quadrilateral and we're going to rotate it 150 degrees around the point P. Notice there's no coordinate plane. We can't use any of our rules. We're going to need a protractor, in which I've simulated here, and you're going to need your compass. So let's get started. I've got the 150 degree angle already denoted here. I'm going to drag my protractor up so its vertex is at the point P. I'm going to rotate it so I'm aligned with one of the sides, in this case GP. And I'll take my straight edge and just draw a ray out there. Now I'll move that protractor out of the way. That's giving me the 150-degree angle right here. Then I'll need my compass. Swing my compass through the point G, and where it intersects my newly drawn ray, that's going to be G prime. So we've got the first point. That was really quick. Let's hide these construction marks so we don't get confused. Let's do it again. I'm going to go for the other easy one, vertex at P, and I'm going to line up with J here. And again, I'm going to mark out my 150-degree angle. Moving the protractor out of the way, I'll take my compass from P, passing through J. When I swing the compass over here, I get a congruent segment, and that's going to be J prime. Okay, let's hide those construction marks. One more to go. This one's a little confusing because there's no segment there from P to F. Well, then draw one. Or you could just line your instrument up without doing that. I'm going to put the vertex again at P, and I'm going to line it up with my newly drawn ray there. And my final ray goes in here. And all I need now is to mark my final distance. Let's move this thing out of the way. With my compass. And I'm transferring the distance F, or P to F. And that would be right here. I'll call it F prime. Hide all the construction marks. And we're done. All we have to do is draw the figure. 1, 2, 3, 4, and we're finished. Now, this is an interesting problem. This would be number 36 in your textbook. We're going to graph the line y equals 2x minus 3. I already got that done for you over here. And we're going to rotate it 90 degrees, 180, 270, and then 360 about the origin. And we'll see if let's see what we can determine from that. For your convenience, I put the rules over here on the corner in case you've forgotten them. So let's first start by identifying a couple points. I'm a little ahead of you. I picked 2 already. Let's go for integral values. 0 and -3, the obvious y-intercept of this line. And I picked the point 2, 1. Instead of dealing with fractions, I thought it'd be cleaner if we just stuck with some integral values. So let's look at the first rule. Rotation for a 90-degree angle. AB maps to opposite of BA. So 0, -3 would rotate over to 3, 0. 2, 1 would map to -1, 2. All we'd have to do is plot those points and then connect them. Let's see. 3, 0 would be there. -1, 2 right there. When we plot our line, it looks a lot like that. Now, let's try another one. Now, I guess we can hide that one so it's not taking up so much room. Get rid of these points. Let's go for another translation. Let's go for 180 degrees. AB maps to -A, -B. So 0, 3 would map to, 0, -3 would map to 0, +3. It'd be right there. 2, 1 would certainly map to -2, -1. So I have those 2 points. And again, I would generate this line. And that would be my rotation of 180 degrees about the origin. Okay, Let's look for one more. How about if I go for my 270? Well, 0, -3 will rotate to -3, 0. And 2, 1 would rotate to the point 1, -2. 1, -2. And we just connect those lines. And let's see. This line. So let's review the 3. Well, get rid of all these lines. Let's start over. The 90-degree rotation looks like that. A line that's perpendicular to the original line. The 180-degree rotation, parallel to the original line. And the 270-degree rotation will be perpendicular to the original line. And the 360, which, sorry, I was lazy, I didn't do that. Well, that's going to map back onto itself. So there you have it.